Okay, in this program, we're going to be using a variable type that is specific to these kinds of conditional statements, and it's called a Boolean. It's actually named after a guy, George Boole, who wrote some mathematical stuff that this is based on. So what we're going to do to declare a Boolean variable, we'll just call it bool, and in this case, we're just going to call it x. Doesn't really matter what it is. This is just sort of a trial program. Okay, so now x can get the value true or false. But let's see what happens when we actually see out x. So if I run this program, there we go. So if I run this program, here's what we get. The number 1. So we set x to be true. The value of that is 1. After this, so this will be output 1. Now let's see what happens if x gets switched to false. And then we're going to repeat this line. So cout x. So we'll run it again. And here we get a 0. So output 0. So now we know that this is false and this is true. So if you remember where zeros and ones are frequently used within computers, they are for binary. So on or off, true or false. So Boolean can only be the value 1 or the value 0, but we can also refer to it as being true or false. So let's see some things that we can do with this. So one of the things that we can do is we can make x become equal to 1 is less than 7. And then what we can do is we can, yet again, we're going to see out x, and we will get the result of, okay, is 1 less than 7? So we can run that. And we get a 1. So what we can do is we can actually do comparisons like this. The other thing you can do is we can directly see out. I don't know why you would ever want to do this other than to test some values. We can, let's reverse this. So we can see out 7 is less than 1. So is 7 less than 1? Well, no, it isn't. So we're going to get a 0 for this. So we're going to get 1, 0, 1, 0. So let's do a few more complicated things. So x is going to get the value of, let's say, 5 is equal to 3, or 3 is less than 6. Now, is this going to be a true statement or not a true statement? So for this one, let's actually put the comparison here into our output. So you can do a copy and paste. It'll save you a little bit of time and make sure that you get it correct. Okay, so let's see what we get as a result for 5 is equal to 3 or 3 is less than 6. So we get a 1 here. So why do we get a 1? Because 3 is less than 6. 5 is not equal to 3, but when an OR happens, only one side needs to be true in order to get this to work. So let's switch this to I'm going to copy the whole thing and switch this for an and we'll see what happens. So, oh, you know what? We should also change that in the output. I'm going to run that again. Okay, so we get 5 is equal to 3 or 3 is less than 6 is true. 5 is equal to 3 and 3 is less than 6 is false, because when there's an and, you need both sides to be true. So I'm going to show you one more interesting thing that you can do, although often I use it to just make these situations a little bit more confusing. So imagine we had x is going to be equal to, now we're going to make multiple comparisons here. So we'll go 5 is equal to 3. So we're going to keep that scenario in here. And then we're going to do or. And what we're going to do is we're going to do a comparison here. Now, bracketing is going to be important when you really have a lot of different things that you're comparing. So I want to check to see if 2 is less than 7 and 12 is greater than or equal to 2. And then we have to be very careful with how we are bracketing these things. So then I'm going to output that. Copy, paste. I'll keep my colon there. There we go. So I'm going to run this. And what we get is that is true. So what it does is it does brackets first. So it evaluates this second half first. So it checks to see if this is less than 7 and this is greater than or equal to 2, which is true. And then it does an or between these two. Now, if I switch this for an and, sorry, I'm going to do this in a second step here. So we'll copy that, paste, and now we're going to switch this to an and you should be able to predict what's going to happen here. We'll run this, and we get that that is false now because of the and. But check this out. What we're going to do is we are going to reverse this 5 equals 3. So what I want to do is I want to check to see the opposite of 5 equals 3. So what I'm going to do is I'm going to put an exclamation point in front of 5 equals 3. So this is, we've seen this before, this is for not equals. So not, so we've got to put it up here as well. Not will reverse whatever comparison follows it. So now if we run this again, we find that this is true. So what it does is this is false, but this is a true statement. So we're checking to see if 5 is equal to 3 is not true instead of if it is true. So this is where things get really confusing. So you can use an exclamation point here to make that comparison. Now, what we want to do here is let's check to see if 5 does not equal 3. And what it's going to check to see if 5 not equal to 3 is not true. Now this is where it gets really confusing, and we find that this is a false statement, because this in here is a true statement which gets turned to a false statement. Even though this entire side is true because of the and, we've got a true side and we've got a false side, so an and gives us a 0 in the end.